Hi guys, today's lesson is on 2.5b. This is day 2 of our next section, and we're going to be working with radians this chapter, as we continue in chapter 2. So quick review, please convert 30 degrees, 45 degrees, 60 degrees, and 90 degrees to radians. Okay, so please remember that what we're doing is multiplying by pi over 180, and when you do that, hoping you guys are showing your work, I think you should get pi over 6, pi over 4, pi over 3, and pi over 2. Now, I want you guys to start to memorize these 4 measures. Well, at least 3, okay? So the 3 right here are the 3 that you must have memorized. How can you help, or how can I help you memorize them? The 45 has a 4 in it. 3 and 6 are the opposite of what you think, right? So 30 degrees is a smaller angle, so you need to divide by the bigger number. And 60 degrees is a smaller angle, bigger angle, so you divide by the smaller. So you can think 3 and 6 and 6 and 3, okay? So that being the case, what we're going to do first is fill in the unit circle with degrees and ordered pairs. Okay, so hopefully you remember how to do this. We're going to take a moment and fill this all in first. If you're able to do this yourself, please do not hesitate. I'm going to talk through just the first quadrant to make sure you guys remember, because it's been a while. So let's see. I'm going to start with 0 degrees here. And when we go all the way around, this will be 360 degrees. Since the radius is 1, our ordered pair is 1 in the x direction, and 0 going up and down. Okay. The next thing I'm going to do is actually do all my 45s. Okay, if you guys remember, like, the best way is to go with your angle families. And so this is my 45, 45, 90 triangle. And hopefully you remember that a 45, 45, 90 triangle has a measurement of root 2 over 2 and root 2 over 2 when the radius is 1. So this is going to be 45 degrees, and then root 2 over 2, and root 2 over 2. At this point, if you are counting and adding your way across, you're going to add 45, add 45, add 45, but we know this is 180, so that's a checkpoint. Add 45, add 45, add 45, right? So hit up all the red circles right now. Our next triangle is a 30, 60, 90 triangle, which can look like this, or twisted, right, or like rotated. Remember that it's 1/2 for the short side, and root 3 over 2 for the long side when the radius is 1. So if you have this, then we can count by 30s. So here's 30, 60, and 90, right? And you can hit all of the other points, but remember to hit the quadrants again. And this triangle right here now, there's a long side in my x direction, so that's root 3 over 2, comma 1/2. And then this one is the flipped x and y values, right? Because we're going to have now in the x direction a short side and then up. So this will be 1/2 root 3 over 2. Now, when you guys fill in the rest of your unit circle, you are going to make sure that anything with the same reference angle, so notice this is a 30-degree reference angle here, right? And this is a 30-degree reference angle, 30 degrees, and 30 degrees, sorry. These 4 points then, 1, 2, 3, 4, are going to have the exact same order of pairs, but with different signs. Okay, so I'm going to actually pause my video here. I want you guys to pause as well and fill in the rest of the circle yourself. You will have a quiz on this next week, so you definitely want to try on your own versus like waiting for me and copying. Okay, so that's all my degrees and ordered pairs filled in. On your quiz next week, that's the first thing you'll do. And then now we're going to go through and do all of my radians, but we're going to follow the same pattern. And that is we're going to count by the same size pieces, right? So I'm not going to go 30, 45, 60. I'm going to count by 45s first, then I'll do 30s, right? So let's start. Ready? So here we have 0. I'm going to go to 45. And we know from up here that counting by 45s is pi over 4. But another cool thing is that what we're really doing when we're counting by pi over 4 is we're dividing into from 0 to pi into 4 pieces, right? So this is pi over 4. And then we have 2 pi over 4, 3 pi over 4, 4 pi over 4. So now let's do that here. Ready? So here, this first one is pi over 4. The next piece, when that one counts, is 2 pi over 4. And that one can reduce eventually. I'll come back later. This next one is 3 pi over 4. I'm going to go all the way around. Always count your axes if you need to. This will be 4 pi over 4. The next 45 triangle will be 5 pi over 4. 6 pi over 4 at the bottom. That's going to reduce. And then 7 pi over 4. And this one is 8 pi over 4, which is just 2 pi. Okay. So just to reiterate, every 45 degrees, we're counting by a 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. That brings us all the way back to 0. Let's do a quick reducing on every quadrant. So this is pi over 2. This one will be pi. This one will be 3 pi over 2, right? And this will be 2 pi. If we wanted to count by pi over 2s, you see how this is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, right? Just depending on what you're counting by. Okay, now I'm going to pull a different colored pen just to reiterate that now we are going to count by 30s. So 30 is pi over 6. So this is 1 pi over 6. 60 is double, so that's 2 pi over 6. We have to hit 90, so that's 3 pi over 6, which is the same as that. The next one is 4 pi over 6. We'll reduce that. 5 pi over 6. And this one right here is 6 pi over 6. So that's how I know I'm correct, because I made it to pi and we have 6 pi over 6. So let's keep going. 7 pi over 6. 8 pi over 6. We'll reduce that one. 9 pi over 6. That reduces to here. 10 pi over 6. 11 pi over 6, and 12 pi over 6 is the same as 2 pi, or 0. Okay. So let's just go through and reduce the ones we need to. You'll notice that multiples of 60 can be reduced. So this will be pi over 3, 2 pi over 3. This one is 4 pi over 3, because 3 pi over 3 was that one. This one will be 5 pi over 3. Okay. Now our goal eventually is to not have to use your unit circle. I want you to be able to visualize what angle we're talking about and be able to move from there. So let me show you what I mean on the back. Okay, so the unit circle is great and all, but, and I'm going to quiz you on it, however, we don't actually want to have to pull the unit circle out every time we want to find a trig ratio. So let's see how we can do this. Just a quick review. Back in chapter 1, We said sine was y over r, which is the same as y on a unit circle. Cosine is x over r, and if r is 1, then that's the same as x, and tangent is always y over x. Quick reminder, the 4 that you need to know is just that this is 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay. So when we say find the exact value of each trigonometric function, instead of degrees, I'm giving you radians now. And it says to sketch or visualize. Eventually you'll be able to see this in your head, but for right now, please sketch and show your work. Okay? You don't want to take chances that you get things wrong. We want to do it right so we don't train our brain to do the wrong thing. And then once you sketch the right triangle or the special right triangle, you're going to identify the trig ratio using your y, x, and y over x. Okay? So sine we know is our y, and pi over 3 means that if I'm going from 0 to pi, I'm going to divide the top into 3 pieces. Right? So this is pi over 3, this is 2 pi over 3. So here, this one is my pi over 3. And you do want to be careful and know that this is a 60-degree angle, right? Because if we have 180 divided by 3 pieces, you guys see how like there's one piece here, one piece here, right? Which is the same size. And then we have one piece here. So those 3 pieces are the same, so they're each 60 degrees. And if we want the y value of this special right triangle, we know that is root 3 over 2. Sine of pi over 6. So if I want to divide the top into 6, it's an even number, so I'm going to use this one. And I need 3 pieces in each quadrant, right? Because this is 6 pieces. So this is 1 pi over 6. So the triangle I need now is this one, which is 30 degrees. 30, 60, 90, right? So if for this 30 degree we want sine, which is y, that's this one, which is 1/2. Quadrant 1 is pretty straightforward. Okay. So cosine of pi over 4, that means I'm dividing the top into 4 pieces. That means this pi over 4 is the same as 45 degrees. And so cosine of this triangle is my x value, which is root 2 over 2. Pi over 2 means I have pi and I'm dividing it into 2 pieces on top, right? So this is pi over 2 right here. Cosine is x, which is 0. Now we can get a little bit more complex, right? So now instead of always being in quadrant 1, let's see what happens when we move into different quadrants. So we have sine. 3 is the tricky one because students often draw their like divide by 3 in weird shapes. Please make sure that you know this is a 60-degree angle. You see how like clear that is? Oh, I shouldn't do that one there. Because I don't want just 1 pi over 3, right? This is 1 pi over 3. I want 2 pi over 3. That's this one. Okay, sine is y, so that value is root 3 over 2. I'm going to change this one to a 5 pi over 4 just to like give us some variance. Sorry about that. So if I want to get divided into 4 pieces on top, okay, I need a 5th piece though. So here's my 5th piece, right? And I know I'm counting by 45s because 4 pieces is 45 degrees each. This is my new triangle that I want for 5 pi over 4. And cosine is x, which is negative root 2 over 2. We'll do this one as well. Sine of 4 pi over 3. So I'm dividing into 3 pieces, which is why I did not draw that last x-axis, or sorry, y-axis, because that gets a little confusing. So here's your first piece. Here's your second piece, right? 1, 2, 3. And then I need one more. 4. 4 pi over 3. This one, please make sure you draw a multiple of 60. Sorry, that's not very clear there. I wanted to make sure it didn't look like a 45-degree angle, right? Divide by 3 is a multiple of 60. Or a 60-degree reference angle. So this one for sine is y, which is negative root 3 over 2. Last one, cosine. 6 pieces. That means 3 in each quadrant. This is 5 right here. Cosine is x, so that's negative root 3 over 2. The answers start to look all the same, but they do matter, signs and then just being careful. Okay, everything seems all good and gravy. Tangent is a little bit more work. Please don't try to do this in your head. So let's see. 3 pi over 2 means I'm dividing into 2 pieces to get to pi. So 1 pi over 2, 2 pi over 2, 3 pi over 2. My y is, let's see, we need y over x. Y is 1, x is 0, so that is undefined. Oh, I should say negative 1, sorry. But it's still undefined. Tangent of 2 pi. Okay, ready guys? This is 1 pi. 2 pi is over here. Okay, so y over x. So it is 0 over 1, which is 0. 5 over 3, since the numerator is bigger than the denominator, I know I'm going to be in the bottom quadrant. 3 pieces on top, 3 on the bottom. 1, 2, 3, 4, 5. I drew this in. You guys see how that helps? Tangent is y over x, so I need root 3. Oh, that's a negative. Negative root 3 over 2 over 1/2. Please remember that the denominators that are the same can cross out. So that equals to negative root 3. Last problem. 11 pi over 6. 6 pieces on top. 6 pieces on the bottom. Okay, so 1, 2, 3, 4, 5, 6, checkpoint, 7, 8, 9, 10, 11 pi over 6. That's my 30-degree angle reference, right? And so tangent is y over x. That's 1/2 over root 3 over 2, and 1/2 is negative. So that equals to negative 1 over root 3. Please always rationalize your denominator, which means we have negative root 3 over 3. Okay, that concludes today's lesson. Please do your homework on Delta Math. You can go straight to deltamath.com and log in using your SEQ account.